Hello and welcome to the new video tutorial about the online application tool of TakeOff. Today we're going to focus on importing foil sections that are in several formats as that, or importing from websites as Airfoil tools. So let's go. So to import a new foil section, what we're going to do is press this little plus button we have here, and here this window will appear. So we have four different ways of importing sections. First of all is the very common NACA parametrization. So here we have some NACA profiles that we can just select, or here we can tape whatever NACA profile. So 2412, for example, here this one is existing, 13, this one not. And here we'll see in red the curve coming from this input that we're giving. Now we want the parameterization that we use, which is NURBS, to define the sections, to match as better as possible this section. And for that we're going to use this lower part of the window, where we have the degree of the curve we want to fit and the number of control points. So we just have to click on fit section and it will move the control points, so we have the closest section as possible to the input one. If we want to be closer, even closer to this section, we can add more control points and then just fit the section again. So we will have more detail, but also we have the risk of being a bit more wrinkled. So the same way it works for the NACA, it works for all the rest of the sections. So if I click on whatever other NACA, we have 4 digits and 5 digit NACA parameterization. So for example, this one, we just fit the section and it has fit the section. Once we are happy with this section and when we want to import it into our project, we just click on save. We can change the name here. We just click on save, and you see here it has appeared here, and we can make all the rest of the calculations with this section. So let's have a look now on what more options do we have. We have NACA and we have Airfoil tools. So Airfoil tools is a website with a huge database of sections. You can see here it's all of the sections, and you just click on one of them, and again in red you'll have the shape of the section that that Airfoil tool has, and then we just need to fit the section, and again you will have the as close as possible section to the one you've selected. Again, you can change the name you want and just save. If you don't want to take that section but you want to flip it, this will flip the red section. So now I can fit the flipped section. Okay, you have, as you've seen in previous chapters, you have the way of flipping the section in the 2D viewer, but you could do it from here too. Then another source of section is UIUC, again another website where you have a huge amount of sections in the database. So again, you just click on one, it will appear in red. Now we're gonna flip it again, we're gonna fit it, and again you have your section ready. You'll see the quality of the section sometimes is a bit kinky, so the program does it as better as it can to match the section geometry. And again, you can save it. And here the third one is one of the most useful ones, which is take a section that you already have in different types of formats and import it into the tool. So to do so, we have different types of formats. We have an ARF format, that format TXT, which basically is the same, CSV, and iges. Let's start with the ARF. The ARF is a format that several tools use, and we can import it directly into the tool. In the ARF profile, we have directly a NURBS parametrization, so you won't have a red curve because it's not points, it's directly the NURBS parametrization, and you directly have the curve itself. So here I have some demo ones. So for example, an ARF section, and you see that here we don't have the red curve because the ARF contains directly the NURBS information. So it's directly the section of the ARF. And then we can just save it. And again, we'll have it on our project. The second type of format is really known format, which is typical DAT files and TXT files, which is the 2D coordinates. Let's show a typical DAT file, show the content. So we have the X coordinate and the Y coordinate of the section. You can also have a header. I don't know if I have a section with a header. You can also have a header, and it will take it into account. The TXT file is the same, and the CSV file is just that the separation is a comma. So here again, if I selected that file, now yes, I will see that I have the points and I have to fit it again. So let's flip it and fit the section. Nice. And now we can just save it. And then the final one, which is very, very useful, you can have an iges. And that is a big jump and a big commodity to import some sections. So basically you need to have, you can have a closed section, an open section on the trailing edge, and it can be in any position. So you don't need to calculate it and put it into a 2D plane and then put it at chord 1 and then to rotate it. You don't care of that. You just have any section in any position. So for example, I'm gonna open this one in Rhino. So that's this section in Rhino. You see it's somewhere in the space. It's not placed like in XY plane or XZ plane. It's just a section in the space. Okay, so I'm gonna select it, and he will calculate or make all the rotations, all the calculations to put it in the correct position. So here you have the points. Then again, you can just fit the section. Now, sometimes it's not as intelligent to be able to do all the work, so you have some advanced import options. So here is how many points you will have per all the file. So maybe you have several curves, and how many points you want him to calculate with all these curves together. Then how you want to space them is if it's a linear separation or a cosinus separation. If it's a cosinus separation, he will put more points on the beginning and the end of the curves. If it's linear, it will just interpolate linearly. Then how you want him to detect the leading edge. So he tries to be a bit intelligent and try to see what's more rounded, if the leading edge or the trailing edge, and say that's the leading edge. But sometimes this becomes a bit tricky, so you can just say the minimum X will be the leading edge, and here it's on the other side, or the maximum X will be the trailing edge. Normally it should work on auto, but this gives you a bit more liberty to find the leading edge or the trailing edge. And then here, these are the default parameters. So this is how he's going to construct the leading edge. So he will start from the leading edge and find the points, because the points can be unsorted. The DAT files and the TXT files can have 3D points too, not only 2D points, and they can be totally unsorted, and he will find his way of constructing the section. So he will start on the leading edge, finding the closest points with a threshold of a certain angle. The bigger the threshold is, the more gentle he will be into focusing on the correct points. But then you can have some errors and maybe some zigzags of unexpected. The closer you are, the more strict it is. So these parameters helps you a little bit if he's not able to find the section of the profile, to be able to relax a little bit these constraints. And then again, on the trailing edge also he has to be more strict, because on the trailing edge you have the let's say the danger of going to the other side points, because these points can be closest to this one, so we have to be really strict in the angle so he can follow smoothly the curve. But again, some parameters, if you click these advanced options, that you can edit. So now let's make an exercise, which I like a lot. I've prepared here a 3D geometry file, okay, whatever shape I have, and now I will want to extract a section from this 3D geometry. Okay, so I'm gonna just select it, click on section, and just make a section of it. Okay, so this section, now I'm gonna file, export selected, and just tell him in the desktop, for example, test section in iges. Okay, save. Okay, and now I can come back to the tool and say choose a file, go to the desktop, and test section that we've just exported. And that's it. It will manage it, it will import it, and here you have the section. That's super useful, and it saves so much time, because this can be done in any CAD. You don't need now to, if it's CATIA, if it's NX, if it's SolidWorks, you just sample the section. It can be open on the trailing edge, it can be closed on the trailing edge. He will achieve to manage, and here you have the section. So on that case, I want it to be positive cambered, so that's it, and then just fit the section and then import it to my project by clicking save. And that's it. And now I have here, if I put the offset, I will see all the sections that I've imported super easily, and I'm ready to work with them. Here I have all the data, the geometrical data, the structural data. I can compare the cambers, I can compare the T/Cs, I can compare the stiffness of all of them, and then we'll see on next chapter how to start working with the calculations. So that's it for this video today. I hope you like it, I hope you find it useful, I hope this can help you in some way. Don't hesitate to ask us any questions, we'll be super happy to answer. Subscribe for the next videos, and thank you so much for listening. See you soon.